Welcome to the presentation on network topologies. Network topologies describes how devices are connected in a computer network. It dictates how data flows and impacts the network performance and its reliability. Different topologies offer different advantages and disadvantages, which we shall be discussing in this presentation. The bus topology. Simple and cost-effective. In the bus topology, devices connect to a single shared cable and all the data travels to all of the devices on the same cable. A failure on the bus can disrupt the entire network, which makes it less reliable. The advantages of a bus network include it's easy to install, it's low cost. The disadvantages are that there is a single point of failure. There's only one wire on which everybody is sending and receiving data. There is limited scalability, and the applications are usually small networks, and there is limited amount of data transmission capability. Then there's the star topology. In a star topology, each device connects directly to a central hub. This allows the central hub to control and isolate problems to individual devices. However, if the hub itself fails, then the whole network goes down. So the hub manages the network traffic and provides a central point for administration. It allows easy troubleshooting because only one of the devices might not be working, and you can find out from the hub which ones is not working. There's slightly increased security because the data is not transmitted to all the devices. It's from one device to the hub and then to the destination device. And the scalability is that new devices can easily be connected to the network by connecting them to the hub. An example of the star topology is VSAT. VSAT is an acronym for Very Small Aperture Terminal. These are satellite dishes which are used for communication between computers and can be used up to like within 1/3 of the planet with one satellite. There are multiple remote terminals, which are called VSATs, communicate through the central hub station. And the central hub is where all the data from the remote VSAT terminals is sent, and the hub processes and routes the destination to its intended destination node. It allows unidirectional and bidirectional communication in the star network. The flexibility is its topology is highly flexible and can handle various types of data, including voice, video, and internet traffic. Commonly, it's used for applications like point-of-sale transactions, remote office connectivity, and internet access in remote areas. Then there's the ring topology. This allows efficient data flow and minimal collisions. The ring topology arranges the devices in a closed circle or loop with the data traveling in one direction. It's efficient with minimal collisions. However, if a single device failure occurs, it can disrupt the entire network. There is a token, and there's a token ring where the ring is actually not physically a ring but could be sort of like a bus medium, and the token is the access to who can transmit at a time. So the ring is defined by the order in which the devices set their IDs, and it's sort of like a virtual ring. So they will take turns in talking, and the only device that can transmit is the one with the token. And error detection, if a device doesn't acknowledge the receipt of a token, that means the device is gone, or other devices detect that some device had a token and did not pass it to the other devices before it is turned off or something, or becomes inaccessible, then the network itself will create another token after a certain period of time. An example of the ring topology is FDDI, which is an acronym for Fiber Distributed Data Interface. This is a network standard that uses fiber optic connections in a local area network that can extend in range up to 200 kilometers. The FDDI protocol is based on the token ring protocol, which I just mentioned, and FDDI LAN can support thousands of users. While FDDI is frequently used on the backbone for wide area networks or campus area networks, it has largely been superseded by other networking technologies. The mesh topology. This allows high reliability and fault tolerance. In the mesh topology, every device connects to every other device. That is called a fully connected mesh. This provides redundant paths for data and enhances reliability and fault tolerance. However, it is complex and very expensive to implement. The advantages are high reliability, fault tolerance, and scalability. The disadvantages are high cost, complex installation, and it's difficult to manage. Examples of mesh networks. A mesh network is a type of topology where each node is connected to multiple nodes, creating a web-like structure. They don't have to be completely connected to every device being connected to every other device. This allows for efficient data routing and redundancy. Some of the examples of mesh routing are home Wi-Fi systems, Wi-Fi mesh like Google Nest Wi-Fi, Amazon Eero, and Netgear Orbi are popular examples. These systems use multiple nodes placed around the house to ensure strong and consistent Wi-Fi coverage. This eliminates dead spots also. Smart cities. An example is Scottsdale, Arizona, which uses a mesh network for its intelligent transportation system. This system connects 90 nodes and 80 video cameras to manage traffic flow and improve the safety inside the city. Hybrid topology. Hybrid topologies combine multiple network topologies to achieve greater flexibility, scalability, and reliability. Usually in hybrid topologies, a combination of star and bus topologies are used to create a balanced approach. The star topology provides central control and isolation of problems. The bus topology offers a cost-effective data transmission method for smaller parts of the network. And the combined advantages are that you get the advantage of each topology for a more robust network. The tree topology. This allows hierarchical structure and scalability. The tree topology combines the bus and star characteristics. The devices are arranged in a hierarchical structure with multiple levels of branching. It's scalable and provides some fault tolerance. The central point for data transmission and control is called the root node. The intermediate nodes connecting to other devices are called the branch nodes, and the devices at the end of the branches directly connected to the network are called the leaf nodes. The meshed star topology. A variation of the star topology is the meshed star topology, which connects devices to a central hub and also directly to each other. It provides redundancy similar to the mesh topology, but with less complexity. Last but not least, we have the point-to-point topology. It's simple and direct connections between two devices. It is used usually for temporary connections or connecting distant locations. It's limited by two devices and offers no redundancy. An example is direct communication, that data travels directly between 2 points. And these days you have got, for example, Bluetooth, which is also a point-to-point connection between two devices, but it's wireless. Choosing the right topology depends on factors like cost, size, reliability requirements, and the applications the network is going to be used for. Each topology has its trade-offs, so selecting the best one to meet your needs is important. The considerations are network size. Small networks can use simpler topologies, while larger networks benefit from more complex ones that actually require them. The cost of implementing and maintaining a network is a significant factor and needs to be considered. The cost is traded off versus reliability. Reliability is made available through redundant paths, which allow fault tolerance and are important for mission-critical networks. The applications shall define the type of data that shall be transmitted and the performance requirements, and this influences the topology which is selected for the network. Thank you for taking the time to see this presentation. Your feedback is important, so please provide feedback so we can improve our courses.